Good afternoon, everybody. Thank you for coming and answering our invitation. This is the 2021 event where we present and celebrate the Lockheed Martin Research Fellows and hear what they've been working on in their projects. We want, of course, to thank the Lockheed Martin Corporation for supporting this program this year as in many previous years. And I also want to thank all the faculty advisors who are listed in the program, which is online. The research opportunity afforded at an institution like University of DC is, I think, very valuable. It's what makes a research university so important for undergraduate and graduate education. It provides an opportunity of research for students and a chance to advance knowledge, and that's what we're basically celebrating today. I will share my screen briefly to put up the program. So this is the program as it appears. I want to make a couple of comments. The first is, given the number of projects within the 3 hours, we want to stick to a 12-minute time limit, which means each presenter should please plan on 9 to 10 minutes for your presentation, and then to leave 2 to 3 minutes for questions. We're getting started a few minutes early because there was a little snafu, and we're adding in one more presentation at the end of electrical engineering and before mechanical engineering. That's for Ribera Hinfesa in here. So everything's going to be, for the last 3 presentations, is going to be shifted back by 1, but we'll get to that in due time. And so I have the presentations to back you up if necessary, but if each presenter, if you can queue up your presentation and be ready to share your screen, I think that's the best, because then you're in charge of when you change the slides. If something goes horribly wrong on your end, then I have most of the presentations and I could be projecting from my screen. So let's get started. Without further ado, we have 3 presentations from the Civil Engineering Department. The first is Calquidan Ayala, Anaerobic Co-Digestion of Food Waste and Fat, Oil, and Grease to Maximize Energy. And his advisor is Professor Hossein Azam. So Calquidan, if you could share your screen, I will stop sharing and get started.
Okay, I'm gonna share my slide. Can everybody see my screen?
Yes, I think I can, yes.
Okay. Good afternoon, everyone. I'm Calquidan Ayala, and I'll be presenting on my Lockheed Martin Fellowship presentation on upgrading of existing water resource recovery facilities to perform the co-digestions. So this is a quick introduction of anaerobic digestion, which is among the oldest process which is used for the stabilization of sludge. Anaerobic digestion involves the decomposition of organic matter and reduction of inorganic matter, principally sulfate, in the absence of molecular oxygen. So water resource recovery facilities is to generate organic sulfates that require stabilizations. So the co-digestion is the addition of organic substrates with the goal of increasing methane production during the digestion. And then water recovery resource facilities being upgraded to perform co-digestion, and detailed evaluation of performance and environmental cost is required for its proper implementation. So the objective here is to determine the conditions that optimize the co-digestion performance and biogas production at different water source capacity. So this is the following are the objective. I have categorized into 3 sections of my presentation, which is in section A is my completed detailed literature review of anaerobic digestion In section B, a performance evaluation of system setup and the data analysis of biochemical methane production. And in section B, SIA have evaluated the system details and data produced from the two bench scales. So on section A, I'm gonna review is literature review of anaerobic digestion. So anaerobic digestion involves the decomposition of organic matter and the rejection of inorganic matter in the absence of molecular oxygen. So the fundamental process here is solid and hydraulic retention times, which is anaerobic digestion, which is the sizing of based on providing of sufficient residence time in well-mixed reactor to allow significant destruction of the volatile solid. The next one is temperature. So temperature is not only influences the metabolic activities of microbial population, but also have profound effect on such factor that has gas transfer rates and settling characteristics of biological slides. And then alkalinity. So calcium, magnesium, and ammonium are bicarbonates of buffering substance that found in the digester. And now we talk about mesophilic anaerobic digestion process. So there are different stages what we're gonna look. So the first one is single stage high rate digestion. Here is heating, auxiliary mixing of uniform feeding and thickening of feed stream characterized in the single stage high rate digestion process. So here the figure A, B is listed here. So the figure B we're gonna look later now. So here is a two-stage digestion. The two-stage digestion, which is was frequently used in the past, is not really now. But nowadays it is seldom used in modern digester system. In the two-stage digestion, a system high-rate digester is coupled in series with the second tank, which is what we looked in previous as the figure B. So the tank may be identical, in which the case is either one may be the primary, or the tanks may have fixed proofs of melting covers in the same as the stage in the single stage digestion. And thirdly, there is the separate stage digestion, which is most wastewater requirement pretreatment plants employing anaerobic digestion, which uses a single digester for the digestion of mixture of primary and biological slides. Now we talk about design for mesophilic anaerobic digestion. So the principle have not been appreciated fully in the past, but now several empirical methods have also been in the digestion process. The purpose of the following discussion is illustrated as one of these is solid retention time, so which is the respiration and oxidation end products of anaerobic digestion that are methane gas and carbon dioxide. The quantity of methane can be calculated with the help of this equation, which is 0.35 is a theoretical conversion factor. So this is the meanings of what is Q flow rate and the influent and the effluent and the X, which is the net mass of cell tissue produced per day per kg. And the other factor is loading factor, which is one of the most common methods which is used in the size of digester to determine the required volume of based on the loading factor. And lastly is estimating volatile solid destruction, which is the degree of stabilization is obtained is often measured by the percent of reduction in the volatile solids. So the methods for enhancing sludge loading and the digester performance is here. So is thickening the digester feed sludge or thickening a portion of digesting the sludge to increase the solid retention time, recirculating a portion of digested sludge and co-thickening with the untreated primary and the waste sludge. The solid concentration in the feed is improved with the performance of the digester. The effect of thickening digester biosolid, either thickening separately or combined with the pre-thickening of untreated sludge, The increased solid retention time of digestion process and production of biogas, and decrease with the hydraulic retention time. The sludge pretreatment prior to anaerobic digestion can enhance the solids flooding and the digester performance. Pretreatment is practiced through adding energy in the form of mechanical, electrical, and ultrasonic. So lastly, combining heat with pressure to cause thermal hydrolysis has been practiced successfully. So here is what we talk about is gas production, collection, and the use. So gas production, which is the volume of methane gas produced during the digestion process. So the gas collection is in cylindrical digester gas is collected under the cover of or the digester, and the gas pretreatment and use is methane gas at a standard temperature and pressure, which is 20 degrees centigrade and 1 atmosphere, and has lower heating value of this amount. So the pretreatment is pretreatment for gonna look into different pretreatment. So one of here is pretreatment for removing moisture, which is typically saturated with water vapor. The pretreatment for removing hydrogen sulfide is which can the piping system and digesters and gas use equipment. Pretreatment for removing cyclones, which is containing volatile organic compounds. And then digester gas used in the co-generation. Co-generation is generally defined as a system of generating electricity and producing another form of energy, which is usually heat in the form of system or hot water.
Let me just interject. You're at the 9-minute mark. Okay.
Okay, sure. Okay, I'll skip some of things because of time. Okay. So now we go into digester heating. So which is described by the question 3, which is Q is equal to overall coefficient of heat transfer, A, which is the cross-sectional area, and temperature. Sludge pretreatment for anaerobic digestion, which is given in the equation forms. So the co-digestion with another organic material. So co-digestion of liquid high strength of organic, consideration for the fog, co-digestion, consider co-digestion of organic solid wastes, and co-effectiveness of co-digestions. So in the section B, we're gonna look into biochemical methane production, which is in the figure 2 is a setup of biochemical methane production. So the measurement of total solid, volatile solid, total solid suspended, and volatile suspended solid will be performed according to the standard methods. This is the characteristics of another food waste will be performed according to the biodegradable plastic, green waste, and sewage paper. So previously, biochemical methane production result is in the figure 3. What we are looking right now is the previous BMP results. So this is in the section C, we're gonna look into the digester experiment. So each digester has produced gas travels through wet tips gas perimeter. Each tip is calibrated to 100
You have 1 minute left, okay? You have
Okay.
1 minute left, okay?
Okay, sure, okay. So previous digester system is in the figure 5, which are looking into the previous digester system. Here is the previous digester system results, the same thing, just a description. In the conclusion, the addition of co-digestive substrate has a negative impact on the gas production. The conclusion of digester here is conclusion of BMP assays primarily select to produce more methane than any other substrate or mixture likely due to the digester pre-existing accumulation to primary sludge. So the future work is continuing performing BMP assays with addition of substrate and mixture. And finally, thank you. Any questions?
Yes, hi. I have one question. You mentioned something about a loading factor at the beginning of your slides, and my question here is that loading factor just a linear multiplier, or do you take into account and make it a non-linear multiplier for any different changes that you might experience from loading?
Okay. So one more thing. Could you explain one more time that the question to be?
No, I know. I just saw something there that you said you had a loading factor, and I was curious as to if that's just a multiplier that you're multiplying something by, or do you look at that loading factor and take into account, okay, you might have some non-linear irregularities and make that loading factor a non-linear function. Maybe this might not be the place to discuss it, but it's just something I was curious about. I don't want to take up your time, so.
You're good at all. So it's not only the loading factor. There are different factors which is corresponding for the digester of
Yeah.
some. Of course. So it is linear as well as multi-linear factor, which is corresponding for the digester system. Among those, these are which is so the loading factor, which is based on the masses of the solid. There are two things which are in the loading factor which are corresponding. One is the mass of solid, the volatile solid added to the digester each day per mass, as well as the second one is the mass of solid added per day per unit volume of the volume of the digester capacity. That are two things in the loading factor which we should focus on.
Okay, I think I understand what you're doing. Okay, it's fine. Thanks.
Okay.